Okay, so just a little follow-up from the Dr. Quantum video that you should have just watched. Um, Hopefully you liked him. It's always good to have a cool superhero, right? Like Dr. Quantum. Um, and hopefully you remembered the double slit experiment with the particle, or with the waves and stuff like we did in grade 11 physics. So now, though, when he does it with particles, that's when we step into the quantum piece. So we're looking at how particles are acting like waves. And the fact that they're acting like waves causes everything to kind of get turned around. He had some really great lines at the end of that video, and I'm not sure if you heard them, so I just wanted to take a second and go back to them. One of the things he said was that the very act of measuring or observing changed the behavior of the particle. So that when we were just sending the stream of electrons through, they were forming a double slit diffraction and interference pattern, just like waves were. But then when we set up something to observe it, then it was like the behavior changed. And he said, it's like the electron decided to act differently, as if it was aware of being watched. So the fact that the act of observing or trying to measure changed the behavior of the particle. And that's what always causes the issue in quantum. As we try to see what an electron is doing in moving around in an atom, our act of attempting to see it changes what it was doing. And I'll come back to that when we talk about Heisenberg's uncertainty principle. But it's tied in with exactly what Dr. Quantum was saying. And his very last line was, the observer in the video, the observer collapsed the wave function simply by observing. So remember, we're saying a particle is moving in a wave. The electron is moving in a wave inside the atom. And at any given moment, we know it's somewhere in this wave, but we don't know where. And the double slit experiment with the electrons, it was showing that the electron, any given electron was going through one slit or the other slit or both. And so at any given moment, we would say the electron is in all those spots. At any given moment, the electron is in this wave. And by trying to find the wave function, we're trying to find exactly where it is. So we're forcing the electron to choose a location, right? And that's what it means by collapsing the wave function. Okay? But, and it's also why we say the best that we can know is the probability, the wave function squared. Because by forcing it to choose or collapsing the wave function, we're changing where it was in a way that we can't predict and we can't measure. So we're screwing up the experiment. Okay, and this is going to lead to our next video, which will be the next day. It's going to lead to Heisenberg's uncertainty principle and Schrodinger's cat. But what I'd like you to do now, before you try the homework questions, which are not connected to this, the homework questions go back to Bohr's calculations, because this stuff would be calculus and you don't have it. But go back and watch Dr. Quantum one more time, just because it kind of stretches your mind a little, and probably after the first time, you were probably saying, what? So now go back and listen, thinking of, so he describes how it works for waves, and then he shrinks you to quantum size, and he looks at how are particles acting as waves? How are these electrons acting as waves? And then when he sets up the eye to try to see, that's when he's interfering with what the electrons are doing, and so their behavior changes. The electron decides to act differently, as if it's aware of being watched. And you should be able to relate to that, because you all do it. When you know an adult is watching, how you act is different than if you're with a whole group of friends in the upper calf, in the basement of your house, the backyard, on the walking trail, wherever you might be when it was normal times. How you act when there's no one around with that group, and how you act when you know you're being watched, two totally different things, probably. Unless you're all just really perfect angels all the time. But even the language you use or the jokes you tell or what, would change. And so in a way, that's kind of what's happening here. By trying to see what the electron is doing, we force the electron to change its behavior, and we collapse the wave function. We make it pick one spot. So instead of saying it's in all these different places at the same time, Dr. Quantum was saying, there's two slits here, and you send one electron in, and it goes through both slits. Like, that part should have caused you to say, what? How can one particle go through both slits? And that's what makes quantum a little mind-stretching. Okay, so go back and watch Dr. Quantum, and then practice problems for this evening, 593, numbers 13 to 17. But I think I want you to skip 16. I was just doing them in 16's where. So 13, 14, 15, and 17. Okay? Very good.